like there's a lot more weight on the end of that lever, and then when the pendulum's here, there's hardly any weight on the pendulum or on the lever, and you'd be surprised how much you can get lifting up and down from the other end of the lever. You know what I mean? But how do you keep the swing of the oscillator? Which
By shifting the weight from one side to the other at the right time, just like you described.
electromagnet. You can use an electromagnet. When it's way over here, turn it on to repel. Gets over here, turn another one on to repel. Over here, repel.
All right.
You
And
know.
that's without using water, but using electromagnetic fields.
How many times do you see electricity explained using water? You know what I mean? And eventually, like my fountain outside with those two streams of water, and what I've seen from other people's experiments is that the current will switch back and forth. 1 minute this side will be positive, and then it'll be negative. Positive, negative.
So maybe the water is stimulating an alternating current.
Well, it obviously alternates, so that's where it's like, where is it getting, how is it separating the two charges is what I'm trying to figure out. It's going to, where the water's dropping through, if you do one left-handed, one right-handed, I should be able to either control, I don't know, like I said, at first before I can experiment with it, you know what I mean? And right now it's been like one of those experiments I've been tinkering, kicking around for like 2 years now.
It must be separating the charges on flow direction.
Exactly. So a lot of things I plan on doing.
Okay, it's got to have something to do with 90-degree angles, 45 degrees. You know, all this is flow. These are flow degrees. You know, and of course you could flow it at 45 degrees would be your optimal flow degree. You'd be right in the midpoint between ground and vertical, and horizontal and vertical.
The magnetism is traveling this way. Your electricity is running this way.
And they also say that the amps leads the volts by 90 degrees. I'm sorry, the volts leads the amps by 90 degrees. What? What? In phase, right? I guess. In the phase, it's ahead of the amps by 90 degrees. The volts is the pressure.
The amps are the pressure.
No, the volts is the pressure. Amps is the flow, is the rate of flow. Volts is not flow. Volts is pressure. The amps is the rate of flow.
No, the amps is the pressure. The voltage is the rate of flow.
It may feel like that when you get shocked, but it's not the case.
So in the cooler, the more water I have in it, that would be like more amperage. And then the voltage would be like the stream of water coming out of it.
The voltage is the lake. It's the water sitting in the lake. It's all the pressure. You lift the lake up, create a degree of angle. Now you have amps, but it's still, you're not going to change. Your amps is always sitting in the lake, but it's got no flow. It's 0 amps. It's no amps. It's all volts. You have to lose volts. You have to drain the lake and lose some volts to create that flow.
Blame my dyslexia. You're right.
I'm telling you, I've been through this. I am sure of this. The lake is holding your pressure, and it's pressuring down vertical. That those amps are not flowing anywhere. They're not moving anywhere. They're sitting in the lake, and so they're 0 amps.
I'm just trying to remember all the.
They're not amps. They've been converted to volts. So you when you lose your volts for amps.
I'm just saying, I'm so used to water and electricity being compared to each other that I'm just not.
Well, the thing, electricity is I just potential volts. Potential is what volts is. It's potential, and amps is flow. I wouldn't call it anything else
Well,
because then you'll get confused.
yeah,
Rate of flow, because that flow can slow down or speed up based on your tilt, how much you tilt that lake, or what is your angular momentum of to give you that flow.
I was pretty much told that, like the diameter of the pipe would be your voltage, and then the amount of pressure on that small diameter was your amp. And I mean, using water and electricity, I guess that's how it was explained. Because no matter how much pressure you put that water on, you're only going to get X amount going through that hole.
Right, but you can increase the pressure or the volts and you push the amps out.
Through that hole by, increasing the amperage.
Right, so if you have a big lake sitting on top of that thin pipe, you still have all that pressure.
But the higher you fill that lake, the more pressure you have.
Exactly, the more volts you have.
And when you watch the water come out of that hole, when the lake's barely full, it's just going to be like, boom, comes right out of the pipe and falls right down. Now, when you got it all the way full, that water's going to shoot out a wave and then fall down. So that would be how the amps are like pushing, you.
Yeah, it's going to be at a high pressure, so
Yeah, it would be like